بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد أشرف الأنبياء المرسلين وعلى آله وصحبه أجمعين. Ladies and gentlemen, I would like to welcome you to Qnrf's Research Outcome Seminar, which is on artificial intelligence and its applications. Qnrf organizes a series of seminars to present the outcome of its funded research. And today we are going to talk about some of our funded projects on artificial intelligence. I am Dr. Munir Tag. I am a Senior Program Manager for Information and Communication Technologies at Qatar National Research Fund. And welcome you all to joining this session. Thank you very much for joining. And this is for you, for those who don't know about Qatar National Research Fund. Qnrf is a globally recognized research funding agency that was established in 2006 with the objective of enabling and supporting world-class research and innovation that addresses Qatar's priorities and has the potential for impact and supporting a knowledge base and economy and society. We have funded a number of projects in different areas. We have four key areas which we are focusing on at Qnrf. Basically energy and environment, which is a huge sector, computer science and ICT, health and biomedical sciences, and social sciences, arts and humanities. All these areas were established based on discussion with the stakeholders, based to detect the priorities for Qatar, to capture the priorities, and to focus on specific areas under these four pillars. So I would like to welcome you all again. The Research Outcome Seminar actually was created by Qnrf as a platform to showcase the outcome of our funded research. And here we are going to talk about artificial intelligence and its applications in the state of Qatar. And it also aims to stimulate research and development and innovation to create knowledge and find solutions to economical and societal challenges in the country. And also, it is an opportunity to network and collaborate. We used to have this ROS as a physical gathering, but because of the challenges, we are having it virtual. But it's also an opportunity to listen to the presentations today, and maybe you can also, after the presentation, interact with the speakers in view of collaboration, joint work, and also maybe submitting new proposals to Qnrf. So. One second. Yeah. So Qnrf actually has a number of funding programs. We have programs for capacity building. We have programs for research and innovation, and we have also research connections. So for capacity building, we have programs for high school students. We have here K-12 programs to support innovation, new ideas, and also competitions. We have programs for undergraduate research students, which is quite successful. We have programs for graduate students and postdocs. We have programs for young scientists, and we have also special programs for teachers. Regarding the research grants, our flagship program is named National Research Priorities Program, NTRP. And today we have this program running for more than 13 years. And the funding for this program, a project here can go up to $700,000 and up to 4 years. So we have a call for proposal that is running now and under evaluation, which is already the NPRP 13th cycle. And hopefully we'll hear about the results, inshallah, soon, before maybe the end of the year soon. We have also NTRP Cluster program, which is a larger version of NTRP standard, NTRPS. Here we call it NTRPC. And here the funding can go up to $5 million for a project up to 5 years. Here, what's the difference here? The projects are much larger in scope, multidisciplinary, multi-institution, that collaborate between different institutions and teams to reach a common objective, which is, of course, which satisfies the priorities and aligns with the priorities of the country. We have also programs for joint research funding programs. And here we have collaboration with other funding agencies like TÜBİTAK in Turkey. We have a joint collaboration with DIFI on USRA, social science. We have also a program on personalized medicine and also on Bellman Forum. So these are programs of joint funding. For instance, TÜBİTAK program. Now we are in the third cycle. We fund Qnrf the Qatari side, and TÜBİTAK funds the Turkish side, and both of them work to achieve a common goal. And then we have research connections like the CWSP, which is a conference and workshop sponsorship program. We have the research outcome seminar, which we are having today, and other activities like also a platform for capturing the publications and outcome of the project Brio, which is also the best image, and also FAME Lab on communication. So these are about a snapshot on our funding programs. Of course, if you need more information, you can get in touch with us. I'll be really pleased to give you more information. Qnrf has been in business, as I told you, since 2016. Now we are going to celebrate our 15th anniversary. Thanks to Qnrf, we have been able really to create partnership all over the world. So Qatar now is connected to all the continents almost. So we have collaboration, the Qatari institutions here in Qatar, we have collaboration with the United States, with Europe, with Asia, with Africa, and Oceania, Australia and New Zealand. So we have 695 institutions actually collaborating with Qatar on projects funded by Qnrf from 55 countries, which really gives a great visibility to Qatar, enhances collaboration, joint work, innovation, and also patenting. So this was quite successful, and now Qnrf is known, it's on the map. Qatar is on the map. Qatar Foundation is on the map, and this is also thanks to Qnrf effort in promoting research and innovation all over the world. In terms of priorities, I mentioned we have the 4 pillars: energy and environment, ICT, health and biomedical sciences, and social sciences, arts and humanities. But let's zoom into computer science. And in computer science, we are addressing different areas. Computer science is a rapidly growing and expanding area. And under computer science, we are currently focusing on artificial intelligence, which is the topic of this seminar. Cybersecurity is one of our key areas. Health tech, which is application of ICT technologies to the health sector. High performance cloud computing, infinite computing, which is also an area of growing interest. A next generation network is evolving. Technology is advancing. Bandwidth is expanding. So here we are focusing on the next generation network for Qatar. Smart cities, which is also an area that is important to Qatar, and we have a strategy with the Ministry of Transport and Communication on Smart Qatar. Smart grids, which is also a very important topic for Qatar, mixing traditional networking to the smart grid and photovoltaic or different renewable energy together, and providing energy efficiently to the consumer. So these are the areas we are focusing on under computer science and ICT. And just for your information, we funded a number of projects in these areas so far, in the different areas. And in data science, data analytics, AI, and machine learning, we funded about 23 projects that deals with this topic of machine learning, data analytics, artificial intelligence. The amount of fund that was disbursed by Qnrf for all these projects under ICT represents about 21% of the total NPRP funding, which is about $234 million, which is quite huge, I would say. But it's really creating good outcome, very interesting publications. We have also patents, and we have also some companies spin out of this research.
Dr. Munir, I'm sorry for disturbing you, but your slide is not moving. Are you switching the slides?
Yes. Which slide you are seeing now?
We still see the first slide, the intro, where it shows Qnrf logo and your name.
No, I was switching the slides. That's strange.
Okay.
Can you see the second slide?
And share again?
Do you see the second slide?
No.
Just a second.
Stop sharing and share it again.
Do you see it now?
1 minute.
Yeah, we see the second. Oh, yeah, we see it. I mean, wherever you are. Yes.
Yes.
Yeah, we see the 4 pillars now, the slide with the 4 pillars.
Do you see the first slide now?
Which
slide? Which slide you see now?
1 minute.
The first one.
The first one.
Okay.
Can you please go to the full screen mode? Okay. Can you please move to the next slide?
You see the next slide?
Yeah. Okay. So yeah. So you probably start, Dr. Munir. Resume again.
Sorry.
Sorry for interrupting you. Thank you.
Should I restart?
Yeah, go ahead.
Yeah, apologies, colleagues, that there was a slight technical problem on the slides, but as I mentioned to you, that Qnrf is supporting 4 pillars, which is energy and environment, computer science and ICT, health and biomedical, and social sciences, arts and humanities. And it's a global funding agency that funds research in collaboration with different countries. And we have 695 institutions funded by Qnrf, which are collaborating with Qatar, with Qatari institutions, different institutions, and which is quite successful. I mean, and we have really good interaction and networking with this collaboration, and they are creating new programs and new projects locally within the same institution. Thanks to this collaboration. This collaboration allowed to expand the scope of partnership and cooperation with other countries. So in computer science, as I mentioned, we have the areas of interest and of focus, with our thematic areas for Qnrf are artificial intelligence, cybersecurity, health tech, high performance computing, next generation network, smart cities, and smart grids. And we funded about 23 projects in the area of data science, data analytics, artificial intelligence, and machine learning, amounting of $234 million, which represents about 21% of total Qnrf funding in NPRP. Now, just a quick history about AI. AI is not new. We started to hear, since recently, more and more talks, speeches, publications on AI. But AI actually was there since the 40s. Between the 40s and 60s, we had the birth of AI in the wake of the cybernetic systems. Then in the 80s to 90s, we have the expert systems that use AI and robotics applied it to the industry. So we noticed an industrial revolution at that time. And since 2010, we have a new bloom based on massive data and computing power. AI requires huge resources. You know, you have to process the massive amount of data. That was not easy in the past, where it used to take time. Now, with computing power and having cheap and massive data availability, we are even really able to go to a different scope of using AI and applying AI in different domains. In Qatar, in 2019, we have national artificial intelligence strategy for Qatar that was created, and which really aims at capacity building in this area. The data sharing among the stakeholders and partners in Qatar, because you need data for AI to work. You need data. It will allow to creating new jobs in this area in different sectors, and it's applied to different areas. AI can be applied to oil and gas, food security, cyber security, Arabic language technologies, and also all of these have challenges with regards to ethics and public policy. Then this has also to be addressed on the application of AI in the different sectors in daily life. We have also in 2020 a strategy that was launched by Qatar Research Development and Innovation Council, QRDI, and it's called Qatar Natural Research Development and Innovation Strategy 2030. And this strategy actually draws the roadmap for the future, where Qatar is going, where we should focus on up to 2030. And AI really is a key area in that strategy. And we will be hearing more presentations on these topics on the strategy and AI. So in terms of AI and its applications, one of the important applications is the AI system. So we need to have performant AI system with performant algorithms, performant platforms, trusted and secure infrastructure, providing AI as a service. We don't need to create AI and algorithms every time. You need to have a generic platform that has the right algorithms that can be customized and that can be applied and support different areas. So for instance, we have a generic platform and providing AI as a service. This is something that is important to work on. We have application of AI to healthcare for detecting, predicting, and controlling epidemiology and infectious diseases, discovering of medicine, imaging, neurology. So these are areas of applications currently of application of AI. Energy exploration, modeling of reservoirs, simulation, characterization, and production optimization based on the data, machine learning. It allows you to take informed decision based on AI. National security naturally is very important. Using AI on data, the correlation of data, it gives you information to predict crimes and things like that, and also to protect your system and your network. Crowd management is an application to that, and also autonomous vehicles. In business, economy, and finance, AI is very important to predict and analyze market performance, trend, and resilience. In industry, we have Industry 4.0 to enhance production, predicting of faults, and optimizing the supply chain. AI really is a key element in applied to industry. In education and personalized learning, AI really assists and for assessing students in real time. So you have bespoke, customized learning for the students using AI system. And in sports, you can have AI to improve the performance of champions, to simulate a game. For instance, you can play a game virtually before you play it physically by programming, by having AI to simulate the behavior of your opponent in a match. And so you play the game and you see what are the best strategies to win. And then before you go to play the match on the playground. We have a special call by Qnrf on AI, which is Ntrp Cluster call, which is, as I mentioned, the bigger call. And we received many proposals in this area, and they're in the process of being evaluated. So these calls actually are aligned with the national strategy for Qatar on AI, and also aligned with the QRDI strategy 2030, which I mentioned before. Now, this seminar has a number of presentations by promising projects. We have many projects. Actually, we have just only a selection of the projects we are having, but we have much more projects that we really wish to present. But due to the to the duration of the seminar and time constraint, we really selected this one. So we have one on National Artificial Intelligence Strategy for Qatar by Dr. Sanjay, who will be the next speaker from Qatar Computing Research Institute at HBKU, and he will be the next speaker. I give the floor to Dr. Sanjay, and thank you very much for your attention.
Thank
Dr.
you,
Sanjay.
Yes, thank you, Munir.
Dr. Sanjay is a research director at QCRI.
Okay, 1 second. Just... Okay. Do you see my screen? No. Yes. Do you see my screen? Hello?
No, we don't see your screen. Yeah, we see your screen, yes.
Okay. Okay, so thank you, Dr. Munir, very much. So I'll briefly speak about the National AI Strategy for Qatar that Dr. Munir mentioned briefly. So my name is Sanjay Chawla, and I'm the research director of a group in QCRI. It's called the Qatar Center for AI. And this strategy was developed in collaboration with the Ministry of Transport and Communications. So as Munir already alluded to, there is, I guess, a resurgence in AI. Munir mentioned about, having origins in the early 50s. But what is new this time, I guess, perhaps it's the convergence of big data, it's the convergence of algorithms and computing infrastructure, which is, I guess, propelling a new AI revolution. So, not only, and we can see the impact, in our daily lives. We are constantly being bombarded with data, whether it's through social media or through other sources. And there's a lot of data in Qatar too, which, we are hoping, at least that's what the strategy alludes to, is that should be exploited. Then there's the algorithms, and there's been several the work in algorithms has been going on for many years, and especially in machine learning, there's been a convergence towards what is called stochastic gradient descent or gradient descent. That's become the meta algorithm for solving many of these AI problems. And then there is the computing infrastructure. So the availability of cloud and GPUs has really propelled analysis and mining and sort of machine learning on top of big data. Just to give an example, the latest sort of the biggest kind of model that is being currently used is called GPT-3. It's used a lot in to generate text, and it was just released in the beginning of the year. That has 150 billion parameters that have to be trained, that have to be tuned or inferred, and it took several $1 million to train the algorithm. And so that just tells you, and in context, the human brain is estimated to have around 80 billion neurons. This model has 150 billion parameters. So, a lot of countries have come up with their AI strategies. Canada was perhaps one of the first one. This AI, the new AI revolution, in some sense, has its origin in Canada. A lot of research work from University of Toronto, University of Alberta, was where reinforcement learning and deep learning sort of came out of. Then many other countries like China, Korea, China, Denmark, Korea here, and the White House had a summit on AI. India also had a document on AI strategy focusing on social justice. So, we collaborated with the Ministry of Transport and Communication, and the strategy was launched by the minister on last year in October in KITCOM, which is the IT conference in Qatar. So this is how the strategy looks like, and I'll basically spend most of the time on what we call the national AI strategy pillars. Of course, the first thing is preparing a data and computing infrastructure for Qatar. Qatar, we need to identify what are the unique sources of data in Qatar. How can they be leveraged? How can we create a computing infrastructure? Should we just buy a computing infrastructure off the shelf, or should we have something unique? In Qatar, of course, there'll be data residency requirements. The strategy talks about that. Qatar is a small country. Can we have some multilateral level diplomatic efforts to share data among small countries? So, for example, in the recent ongoing COVID pandemic, can countries like Singapore and Qatar and perhaps Denmark, learn from the experiences, share some data about how COVID spread in these countries and what actions were taken. Then Munir mentioned about Qnrf having programs for high school and undergrads. So we talk about the race for talent. There's a big scarcity of AI talent in the world, and they can be like a top-down and a bottom-up approach. You can attract talent into Qatar, but you can also encourage high schools to have programs in data science. And here, you could talk about whether there should be a separate course in data science, or should every course, every subject should have a section on data science. So if you're doing physics, can you bring in some data from astronomy and actually show students how to work with it? Similarly, in biology, you can teach math in a way which is sort of focused on data. So the strategy talks about this and also talks about trying to make how can we make Doha as a hub for attracting AI talent? Can we have special visa programs to attract AI talent into the country? Then, there have been many studies on what the impact of AI will be on the workplace, on jobs. In fact, we will be releasing a white paper on this very soon, where we actually quantify what the impact will be on jobs in Qatar. We call it AI augmentation. Jobs are made up of tasks, and some tasks are amenable to AI, some tasks are not amenable to AI. And like in the rest of the world, the conclusions for Qatar are also that white-collar jobs are more likely to be impacted by AI than blue-collar jobs. So then, if that's the case, then some programs have to be set in place to help people transition from the jobs that they currently have to jobs where they can take advantage of AI. Okay. Then the other pillar in the strategy is the knowledge economy. Qatar has a document, the Qatar National Vision, which talks about transitioning from a resource-based economy to a knowledge-based economy. So how can we encourage businesses, AI-driven businesses, to open shop in Qatar, to have a foothold in Qatar? What are the incentives? How can the legal framework be changed to do that? What are those? What should be the what should be the medium, the mechanism where we can attract companies to have a foothold here? What can the research community, what can Qnrf do? I mean, we don't talk about that particular thing in the strategy, but I think it's something that the Qnrf should discuss or debate internally, how to create programs to attract innovation in AI within Qatar. Then finally, we also talk about the ethics and governance of AI. Of course, you've probably heard of stories about an autonomous vehicle getting into a crash, who has to take blame for that? Is it the company who's, who made the automobile, or the driver who has, little control over the vehicle? A lot of ethical issues that have been around for a long time that need to be addressed. Also about data privacy. What should be the mechanisms? What should be the data requirements? So strategy, like many other strategies, talks about how around the ethics and governance of AI. Talks about data bias. There have been a lot of studies in the US about how algorithms which are based on data can be biased, and how can we draw conclusions or inference from them, which is we have to be careful. They are de-biased in some sense. So there's also this notion of explainability, which is many of these AI algorithms are like black boxes. You really don't know why a certain decision is being made. How can we talk about interpretability and explainability of AI? So there's a section on that. Finally, all this goes into the AI plus X future. Here we list several areas where Qatar may have a niche. So we talk about, of course, oil and gas is one area. We also talk about the Qatar Genome Project, precision medicine. We talk about especially QCRI's work on Arab language technology, which is being used in many places all over the world. And so again, try to identify probably niche areas where Qatar would have an advantage. Historically, people have been, they protect their code, but used to share data. But often now data is the new code. People really want to, protect the data, because that's where a lot of you can extract a lot of knowledge from that data, and actually you can benefit from it. So, for example, in QCRI, we are working with Carva, we are working with, some teams are working with Qatar Airways. We're trying to see how data that's available in Qatar, how can we build partnerships and really show that, you can create value out of data in Qatar. So, yeah.
Sanjay, we have one more minute. Yeah, okay,
yeah.
You're done.
Yeah, so that's basically the crux of the strategy. And if you have questions, please go ahead. Or if you want to reach out and have a separate conversation, we'll be happy to catch up. Thank you.
Yeah, thank you very much indeed. If you have any questions, please you can write them, and we can present these questions to the different speakers. Dr. Sanjay, if you have any specific questions, please, if you have any question, you can raise it. I don't see questions. So we'll be moving to the next presentation. And the next presentation is by Dr. Serkan Graniyaz. He is a professor at Qatar University, and he's going to talk about a project funded by Qnrf entitled Personalized Monitoring and Advanced Warning System for Cardiac Arrhythmias. Dr. Serkan, the floor is yours.
Yes, good morning. Can you see my screen and hear my voice?
Yes, we do.
Okay, very well. So good morning, everyone. Yes, I'm a professor in Qatar University. I'll talk about personalized monitoring and advanced warning system for cardiac arrhythmias. We are in the final year of this project, and I'm going to talk about this project and a little bit beyond of this project, what we are doing as a team on the domain of AI. So without further ado, let me show you the outline. I'll start with the objectives and methodology and show you the incoming demo, hopefully in a few months. And then a little bit talk about one slide only, I don't have time, but advances on machine learning and AI. And then I'll change the scope okay, similar scope, but on myocardial infarction, or as you know, with the heart attack, what we have done on early detection of heart attack. And then show us our accomplishments in the past. And then quite another important topic that our recent efforts on the COVID-19 pandemic, especially on computer vision and pattern recognition using the AI, and I'll draw some conclusions. So our original project has basically 3 objectives. Our aim is to detect the cardiac arrhythmia at the moment it occurs. So before this moment, the person is healthy. So how would you then train your system so that the system will notice something wrong going on, and arrhythmia has started, otherwise on a healthy person? So that's the main issue in this project. Well, as you all know, our previous speakers nicely indicated that you need data, but you don't have data about these patients. Especially, you only have the normal data, the regular rhythm of the heart, but not the irregular rhythm, not the arrhythmia. So what we are doing is we are creating this abnormal rhythm artificially, and we are learning from it, from the artificially created irregular beats. Using, at the beginning, we were using convolutional neural networks, CNNs, and now we are using much more advanced version of it, the heterogeneous version of it, the operational neural networks, which is actually developed by our team too, in a better way, in a much higher accuracy. And we are about to integrate this solution into a fully compatible system, in a cloud system, hardware and software all combined. And then, of course, we extrapolate what we have developed in this project to other domains. So for us now, machine learning, novel machine learning paradigms applied on early detection, recognition, localization, and prediction with utmost accuracy and speed of many other critical healthcare problems. This is our main feature right now. This is one slide, what we are doing with the arrhythmia. So that's actually the whole scenario, as you can see here. Anyone can come and register, open an account, and then use our device, the mobile device. We acquire his normal beats, and we get it to our clouds. And from his normal beats, we are creating this artificial abnormal beats, and we are learning from it. So we are learning from our novel machine learning paradigms. And once we learn, this is again uploaded back to the device, the mobile device. It can be a clock, it can be a mobile phone, and with some sensors. And then, of course, this machine learning, it's actually a compact one, will be monitoring the user's heartbeats 24/7. And whenever he notices a real abnormal beat, well, that's the bad news. But for us, it is time to detect it and also store it in the server. And if this abnormal beat starts to increase, we will, of course, warn the user that the frequency of abnormal beats increased. He should see a doctor. And whenever he sees a doctor, he can just go and show his cardiac history, because our system is up and running for, let's say, perhaps a few months already. And the doctor can actually see all abnormal beats stored in the system, and he can verify, yeah, these are really the abnormal ones, or no, these are the false alarms. But anyway, at least his full cardiac history will be available, and that's a very big advantage, especially for, let's say, the early stages of detecting a cardiac anomaly. I hope you can hear and watch the video right now. So this is the incoming demo. As you see in the mobile phone, and we have a sensor which will be attached to the chest. And once it is attached, the chip that you will see on the left side will be integrated into the sensor. Now the chip is going in, and the moment chip is embedded, then the acquisition automatically starts. And of course, since we get it on the server side, we are free to do all our analysis. So this is the what we can see on the server side, and we will start our analysis as we see fit. Yes. Okay, that's all for the project, and I'll extend the discussion about the born of AI and the what is used nowadays.
In 2 minutes, please.
Yes, of course. I'll be quick on from now on. As you see, it starts from 1940s, 1960s are the perceptrons, and believe it or not, even today, after the born of the convolutional neural networks, this simple model has been used. So what we are doing is, recently we have changed to a new network paradigm, operational neural networks, and now we are moving on to the newer version of that. If you are interested of what we are doing on this heterogeneous and nonlinear models of the convolutional neural networks, please contact with me. I can share the papers, recent papers and articles about you. But as a result, I don't have time to show you the difference between them. But in terms of performance levels, there is a huge difference. I can show you this. This is another application on myocardial infarction. So you can make some computer vision techniques. This is the echocardiogram. And normally the cardiologist should look at this echocardiogram and try to determine which parts of this chamber is not moving as well as the other. Well, I mean, with our technique right now, we can immediately measure it. We don't need to estimate it and say that the segment to the red one here is not moving as well as the other. That's probably a blockage of the artery feeding this muscle part. And as a result of that, that creates the problem, and that can, immediately detect a possible cause of heart attack. And this one now is the same thing, but this time we use the deep learning, and we can segment each part, segment 1 to segment 7, and we can also measure. And from this measurement, we can understand that actually number 2 and number 3, they are the problematic ones, and shows the effect of myocardial infarction. These are some old publications in a few years ago. We have the most cited and most popular articles in Transactions of Biomedical Engineering. So this project has actually started as a result of that. In 2007, among 75 teams internationally, we won the challenge, AF classification challenge in PhysioNet. And of course, the results is published on a Nature group in the scientific reports afterwards. Last of all, I'm going to show you some results on the COVID-19. The same team now, we were quite busy in the last 6 months on the detecting and recognizing COVID-19. So this is directly from the X-rays. We can show if the person has this infection, and we also give the infection maps directly on the X-rays. And that's all I would like to show. You can read the conclusions. Our job is now to enhance this work towards more and more accurate manner, so that, again, the last part, detecting the critical health problem at the moment it occurs, is our main objective ever since. Thank you very much.
Thank you very much for your presentation. Quite interesting presentation, quite interesting application of AI, indeed, and actually the strategy and also our priority areas focus, and also the national strategy for Qatar, on RBI. Gives special importance to AI and its applications. Health and biomedical is quite important. This is a question for also to it's just a comment to you and to Dr. Sanjay. We have the strategy now. Perhaps we need to join effort together and have like a task force. This question should be and this observation should be at the end. But I'm just putting it on the table now. We need to think maybe of having like a task force on AI and how to really to go from the strategy towards its implementation and deployment by involving the different stakeholders towards achieving that common objective. Can you give a quick observation on that, Dr. Serkan or Dr. Sanjay, both, I mean, any one of you?
Yes, I would like to say that that's a great idea, actually, because many groups are doing individual efforts on that. And if we have some common framework, common ground to join our efforts, that will be great. I'm fully in. And as a group, what we have is maybe some other groups may not have. We are not using now off-the-shelf AI solutions. We are actually creating our own and getting even better results. So any other group can benefit from this novel AI paradigms that we are developing. That'll be great, yes.
Thank you. Colleagues from the attendees, do you have any questions to Dr. Serkan? There is a question, could you briefly explain the advantage of the new ONN compared to convolutional neural network? So what's the advantage quickly?
Yes, do I have a 3 hours time? This is what we have explained on the last ICIP conference in image processing and machine learning. So yeah, actually ONNs is still developed in 2019. So we moved to self-organized ONNs, and now we are actually working on the super neurons version of it. The main difference is that in convolutional neural network, this is a homogeneous network with only the linear model, McCulloch-Pitts neuron model from 1940s. Believe it or not, the CNNs based on multilayer perceptrons, and multilayer perceptrons have this linear neuron model. It's a fully homogeneous because every neuron in a CNN is linear. What we did is we make a heterogeneous network where the neurons are no longer linear. Like in the biological neurons, the synaptic connections are nonlinear in general. So we created nonlinear neuron models inside operational neural networks. And of course, as you have the heterogeneous network, we have the ability to choose what nonlinear operators should be used in what neuron. So that's the main idea.
Okay, there's a question on the sensor. Is this sensor available today?
Yes, it is available. I think the sensor is about the video that I have shown you, right? It's not about the.
About this, the chest sensor.
This is available. This is produced by a startup company in Turkey. So we are purchasing from the sensor from them and putting our solution on top of it. And we are
what's the name of the sensor? Somebody is asking.
The company's name is MobileMet.
MobileMet. Thank you very much.
Yes, if you Google it, you will find it.
Excellent. Thank you very much for the presentation, Dr. Serkan.
My pleasure.
We now move to the next presentation by Dr. Roberto Di Pietro. He's a professor at Hamad bin Khalifa University in Qatar, and he's going to talk about extending blockchain technology, a novel paradigm, and its application to cybersecurity and fintech. Dr. Roberto, the floor is yours.
Thank you very much. Do you see my screen?
Yes, we do.
Yeah, you see the screen, great. Maybe back to the screen. So this is basically the result of a project which is funded by Qnrf, extending blockchain technology, a novel paradigm, and its application to cybersecurity and fintech. I'm the LPI of the project. If you have any information that you want to know more, please feel free to reach out to me. If you want to see what we are doing in our cybersecurity research and innovation lab, please feel free to reach out. There is also a very nice and updated website which is reported there. So a quick outline, an introduction, of course, then we will see a few applications within the framework of this project of AI, and in particular we will see how AI is helpful in cybersecurity. We use basically AI as a tool in addressing a few current issues. And we will also have a glance at other results and some conclusion. I will try to go fast. The Cybersecurity Research Innovation Lab I'm leading as a vision, which is quite clear, is to achieve excellence in cybersecurity research, not only in research, but also in innovation, with the final goal to have an impact on academia, industry, and society. Project key data for this project. Principal investigators are from the Ministry of Defense, from University of Washington in St. Louis, and my colleague here from HBKU, Dr. Spiros. The project is over 3 years. 1 year passed. We had a stop due to COVID, but research actually never stopped, by the way. The funding by Qnrf has been very generous. For 3 years, the top request was granted, so it's 600,000, and co-funding is for more than 400,000 US dollar. The first application we will see here is an interesting one, I will say, which is related to a very dreadful attack, which is listed by the European Agency for Network Security among the 15 most dreadful attacks. So there is also support, which are later on. We identified this attack before, which is cryptojacking. Cryptojacking basically is when someone is using your computer resources to mine cryptocurrencies. For instance, you're visiting a web page. Nice, you're visiting the web page. While the page is loading, actually your CPU is mining currencies. In particular, this is true for a few of them like Monero, but can also be for Bitcoin, and you can name it, because the applet that is downloaded on your PC actually is providing you the services you requested, but it's also mining for someone else, because if you find a coin, that coin will be transmitted to the illegitimate user. This is an important threat because, as we said, for instance, AI needs a huge amount of computational power. There have been many frauds.
Dr. Roberto, your slide is not moving. Your slide one. Yeah.
I'm still on slide one?
Yes.
Okay. Just again, stop sharing. Sharing again. Do you see now?
We see the first slide. Can you move to the second one?
I am on the third, probably. Okay.
Can you click on the third one?
Can you see it? No. 1 second. Okay, yeah, okay, I understood. Can you see the second one now?
No.
No. Okay.
We see the second one. We don't see the third one.
Dr. Roberto, you need to put your slides into full screen.
Okay. Do you see project key data?
No. We see the slide with the vision.
Vision. Okay, 1 second.
You need to use the full screen mode, Dr. Roberto.
Do you see now vision? Let's move forward. Project key data.
Yes.
Now it's moving.
I discussed. So this is the project now we are discussing, which is cryptojacking. As I say, cryptojacking is a dreadful attack, which is among the 15 attacks that have been listed by the ENISA, which is the European Network Agency for Security. What is this attack about? Well, basically, as I said, while you're browsing or visiting a web page, what's happening is that a software is running on your PC, so consuming your resources, and actually mining cryptocurrency. This is a problem, first of all, because it's violation of policies. You didn't allow anyhow to crypto mining on your servers, and actually is an attack on availability, because if the CPU is mining for someone else, basically you are not able to do the computation. There have been many cases where resources run by universities, but even state research center, have been used by unlawful employee to mine cryptocurrencies. And this is like probably could also happen in our scenario, because as we said, AI needs huge computing power. When that huge amount of computing power is available, if no controls are in place, bad things can happen, which is always the case. So that's what happened here. Basically, you download something or you simply run a script in your browser, and the script is using your CPUs or the server farm within your company to crypto mine. And if a coin is found, that is transferred to the malicious guy that actually downloaded the malicious software. What are the solutions? The problem has been recognized by the community, both the scientific community and the industrial community. There are a few anti-cryptojacking software. Unfortunately, these anti-cryptojacking software are not efficient for external threat and not efficient for internal one. For a very simple reason, they assume to analyze the traffic in clear text. Of course, traffic nowadays is encrypted. End-to-end encryption is the norm. And basically, whenever you're browsing on a web page, you're also browsing that web page in a secure manner. So traffic is encrypted, first of all. So you cannot do, if you rely to the standard solution, you cannot do any analysis just looking at the network traffic. What we were able to do is to come up with a solution which basically just analyzes the encrypted data. And what we did, basically, that's the methodology. We assume to have a cryptocurrency network. We browsed that cryptocurrency network. We sniffed the traffic between the router and the internet, an encrypted traffic. We did feature extractions, and we put everything into the machine learning machine. We do resort just to standard machine learning tools. We use AI as a tool for cybersecurity. And basically, we can come up, and actually we did come up, with a crypto miner network traffic model. So the point is that now that's the way it works. You have scenario one, VPN tunnel or a direct traffic. We are able to do our job in both cases. Just analyzing the encrypted traffic, we are able to detect whether a user, whether there is a crypto mining activities on the machine of the user related to a few cryptocurrencies like Bitcoin, Monero, and Bitcoin. And this works not only if the traffic is from the machine to the internet, but also if the user is using VPN, which is a very difficult scenario. If you're using a VPN, you have an added layer of security, not only encryption, but you're also using tunneling. We are able to detect this crypto miner attack in many, many cases. So the methodology was based using extraction of a few distinguishing features, in particular packet size and the arrival time are very important for us. We use random forest and k-fold cross validation, standard tools, as I said before, but these are the exciting results we are able to achieve. So basically, we have an area under curve, which is a typical parameter for judging the quality of the results you're having, which is close to 1. 1 means that you have no false positive, no false negatives. And we are able to detect, so if the activities, malicious activities are ongoing, even in case those activities are, let's say, mixed with the standard office traffic. So this is a real solution that can be implemented starting from today. And it works, basically. It works under many scenarios and is based on a very good intuition by the research team. So in conclusion, we are able to detect encrypted traffic that is bringing malicious payload, in this case, activities of crypto mining. And this is good because it's also privacy preserving. We don't look at things that are happening on the machine of the user, which could be raising some privacy issues. And this is very easy to deploy. It has basically very little cost and can be a software-only solution. Future work, we have to go for a NOS-based, maybe, and we need to increase the number of crypto coins considered, but the methodology will not change. And already like that, we cover like 80% of the cryptocurrencies, except for Ethereum, that are outside. So this is the first of the many results we have. I decided to go for another one, which is related to drones, the drones threat. The drones are very important and cyber-physical threat to critical infrastructure. Think about airports. A few airports were blocked last year when the airports were running. In particular, Dubai, Milan, Gateway, Dublin. And if you think about what happened in Saudi Arabia in September last year, where drones attacked a facility, you really realize that drones are a very dreadful threat. For the Saudi facility was very well guarded. There were anti-missiles batteries, there were heavy machines, speed rifle machines, was military guarded. Unfortunately, the drones evaded all the attacks and were not able, the defenses were not able to shut down drones. So what we do now, in order to have a countermeasure for drones, first of all, you need to be able to detect the drone. Okay, nowadays drone detection is based on few technologies, basically radar detection, which does not work for drones because the drones we have in mind are like small drones, less than a couple of kilograms. so they can fly even 50 centimeters from the ground, and you will not be able to detect with the radar.
You have 2 minutes, huh?
Yeah, so audiovisual strategies, they don't go very well. Actually, we resort to radio frequency-based strategies. The idea is to intercept the traffic between the drone and the controller. We extract the features. We did that and applied the AI solution and machine learning, basically. We did that in our laboratory on a real case scenario, and these are the results. Basically, we are able to detect whether there is a drone with an accuracy of likely 100%. And we test also different solutions. So novel method to detect the status of powered drones. It's inexpensive and can be deployed even today. We have a lab here where we did the test. So there is another results I will skip. I will just go for further results that we're achieving. We are coming with, actually we published last month, the first solution, the first intrusion detection solutions based on blockchain, because the project is on blockchain. It's advised, is in collaboration with Bell Labs. And we also are doing a great job on some unpublished work in privacy in blockchain-based systems. We come up with 2 results, which will be big results. The first one is a new Bitcoin parser, which is something that overcomes all the Stanford one, its old one compared to this one we're going to releasing. And we also found out a few interesting things that are ongoing in the Bitcoin blockchain. So conclusion for the project is a highly successful project, still 2 years to go, exciting results to come. And this is the number of publications we have achieved so far. We have like 12 journal papers and like 10 conference papers, and also a few patents have been inspired by this project. So thank you very much. If there is any question, I would be glad to contribute to the discussion.
Thank you very much, Professor, for your interesting presentation. There is a question on how to use this. Is it possible to use this approach in for personal and industrial use? Is it possible to expand its use, you know, to actual industrial sites?
Yeah, for when it comes to the drones, yes, the idea is actually meant for critical infrastructure protection, which is
the question about cryptojacking.
Cryptojacking, yes, of course. The solution was meant for businesses, was not meant for home solution. It's applied to home, of course, but it's meant for big organizations, because that's where typically the cryptojacking takes place. Especially, there are few cases. There are a couple of cases. I will cite just one. There is a research facility in Russia where they do simulation for nuclear weapons. One of the scientists there used that computing power to start mining cryptocurrency, and actually it was caught because it was very stupid. He connected to the internet, and that's why the secret services was alert. But it's very possible to apply it to the industrial sector, and actually has been taught to be applied to the industrial sector.
Thank you. This is an interesting project, and also the previous one by Dr. Serkan. So, I mean, both of you, I think, are you collaborating with local authorities, with the institutions, you know, for prototyping, for testing on the field? Your project is interesting, and the one before, perhaps collaboration with HMC will be also interesting. So, are you started collaborating or cooperating with the local stakeholders?
Yeah, we basically have a Minister of Defense. We have regular meetings with the Ministry of Defense, but they are very nice, they are supportive, but the communication is typically one way. We tell them what they are doing. They are very interested, and sometimes we also do some trials in our lab. The other way around, it's a bit more difficult because they do classified stuff, but I'm pretty sure that they're happy with our work, especially for the drones, because drones is a typical dual-use technologies, and if you think what happened to Saudi, it could happen also here. So it's very important work in the field. Indeed, especially for offshore oil and gas fields, that's quite important.
Munir,
okay.
Thank
you very much. Yes.
Can you, yeah, to reply your question, we have 2 PIs, 2 top-notch cardiologists from HMC. They are in the team, and Excellent. We are getting all data from HMC. So we are using actually Qatari data for our research. Thank you. Excellent. Thank you very much.
Okay, so we will move now to the next presentation by Dr. Samer Said. He's Associate Professor at Qatar University, and he's going to talk also of an important and interesting topic on early detection of fake news over Arabic social media. Dr. Tamer, the floor is yours.
Thank you, Dr. Munir. Do you hear me and see the slides?
Yes, we do. Yes, thank you.
Okay. Okay. So, Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Thanks, Dr. Munir and Qnrf for giving us the opportunity to share the progress and the outcomes of our project with the community. Let me start the presentation by where the whole story actually started. It started on May 24th, 2017, when we woke up on the news of the blockade on Qatar that was primarily based on fake news published on the hacked Q&A website. A new page of history of the region has started since then, and also a new line of research has started at Qatar University through this project and even before. This project is a collaboration between Qatar University and University of Edinburgh in UK, and also Al Jazeera as a local end user for our project. Let me start by a motivating scenario. We all follow social media. We might see a post that that will provoke thinking about and wondering whether this is true or false. You might have one of two options. The first is to share this because maybe you liked it, you share it, and in few seconds or minutes will reach the globe.
Can you explain the post in English, because maybe some colleagues don't read Arabic?
Okay, very good. Okay, so I will need more time to translate all of the posts in my presentation. Okay, so this one was about the famous French player Paul Pogba saying that he will retire because of what President Macron said about Islam and about Muslims. So I might be tempted to share this with my friends, and my friends will share it also with their friends and so on, so it might reach the entire globe in few seconds or hours. Or I might wait a second and think whether this is true or fake and check it out. And that's exactly the objective of our project, is to help end users checking out what they see on social media, and specifically on Arabic social media. So we structured the project around this idea. We want to monitor the Arabic social media, specifically Twitter in our case, and through monitoring these posts, we want to first identify which of them are worth of checking further, because not everything that's posted really worth of our time and worth of checking. So we need to identify those that are what we call check-worthy. Among those that are check-worthy, which ones are actually fake? So we want to build models for check-worthiness. We want to build models for for detecting fake news. And then among those who are fake, we want to really analyze how they spread, who was the source, and who were the key influencers behind spreading such fake news. So these are the main components of our project. The main objectives are aligned with these components. We want to build a real-time system that monitor the Arabic social media and detect early, as much as we can, the fake news. We want to identify the source and influencers of those fake news, and thus we help end users in verifying such news. So I will quickly go through the progress that we have done in the last year, in the first year of the project, in each of these components. For the check-worthiness, the main idea, as I said, we have a post and we want to check whether this is check-worthy or not. Is that really worth of our time to check further or not? So if it's not, then we can ignore it. If yes, then of course we need to check it out. What we have built so far is a two-stage solution. We built what we call a representation model, using pre-trained models, fine-tuning them like BERT and its brothers. Out of the representation of the claim in the tweet, we need to classify it. So we have another layer of classification that will give us an estimation of whether this is check-worthy or not. Now, to measure the performance of our proposed solution, we didn't, at the beginning of the project, we didn't find any data set on Arabic data that can be helpful in that regard. So we had to build our own data set. So we went through and collected 7,500 tweets over 15 different topics, and we labeled them based on checkworthiness. We called this data check that 2020, and we released it. And we actually used it in one of the the international research competitions in Clay conference. Here is some examples of our results. I'm sorry that we might not have time to translate all of them. But for example, this is one that says that the Australian police has stopped 2 Swiss people regarding the attack in Vienna, and that was, although it was not published or posted by a verified account, our system thought that this is checkworthy, and in my opinion also this is of course checkworthy, and some of the others of course are not, and these are just examples of our system. Or actually I will show that in the demo as well. Using the data set that we had, we achieved about 78% precision. That is quite good as a starting point. But of course, we are working on improving that. Surprisingly, this is the best among all systems that participated in the research competition on this data set. So we can say that we have developed so far an Arabic AI model that is state of the art using this data set for this specific task. This model has been in testing mode by our partner Al Jazeera, currently in their platforms. The second component is whether the checkworthy tweet or claim is fake or not. We have tried both 2 types of signals to do that. Remember that here we want to have an early detection. Okay, so once we see that there is a rumor going around, we need to quickly act upon that. So we have used 2 types of signals, social signals and web signals. In this presentation, due to time, of course, I will only focus on social signals. So let's think about having a claim now that's checkworthy that is inside a tweet. So what kind of signals we can use? We can use the text of the tweet itself. We can use information about the tweet and information about the author of the tweet. Not only that, we can also use the information about the replies to this tweet, the text that is in these replies. We can also use the retweets of such tweet. We can use the information of authors of those replies and retweets. And if we look at the time, if we look at the past, we can also make use of the other tweets that are expressing the same checkworthy claim and their propagation network also. So we call the replies and retweets propagation networks. So all of this can be available for us to make an estimation, and I want to emphasize estimation here, of whether the news is fake or not. Here is an example again about the Paul Pogba post. We can see that some of the replies can give a hint on the truthfulness of such post, if we can really identify such replies. Approach that we used so far, of course, this is a quick glimpse of our approach. We want to really build AI models that will learn patterns of interaction with fake and non-fake news. Among the patterns that we, okay, I will try to go very quickly. I start a bit late. Among the patterns are the structure of the propagation network, and also the time sequence when these replies came in and when these retweets came in. We use graph convolutional networks for the first, and we use gated recurrent unit and RNN for the second. In terms of performance, again, we didn't have a data set, so we got hours. We collected 1 million tweet at the time. It was COVID-19, so we collected 1 million tweet about COVID-19 in Arabic. That was the first data set of its kind with propagation networks. We released it, and we augmented it with 138 rumors around COVID-19 in the Arab world. We labeled about 10K tweets supporting or refuting such claims. We released it also. Here is an example just yesterday from our model. Of course, our model is still in progress, but this is a tweet from a verified account that says that the difference in votes between Biden and Trump in the US elections is more than 100 votes, and our model estimated or guessed that it is not true with some confidence. Of course, still the model, the precision is not very good. It's about 70% now based on our data set that is quite biased towards COVID-19 rumors, but this is under experimentation, of course. That's again in progress, and our model is the first that is based on propagation networks in Arabic that is developed for early verification of fake news so far. In the third component, we get access from Twitter through University of Edinburgh for about 500 million multilingual tweets about COVID-19. Here the goal is to analyze the spread of those of some rumors. On these two charts, on the left you will find how the amount of tweets on the rumor of injecting bleach will cure COVID-19 is in different languages. Same for the sunlight or ultraviolet light will prevent the spread also on the right side. You will see on the left side that most of the languages, actually 5 out of 6, the peaks of them are very well aligned, but here they are spread, which means that spreading of rumors across different languages or across different countries are really different. There are, of course, more questions that we need to answer: how rumors spread, who are the influencers, and how we can actually build a model that will help us in verification. This is just started. Now I want to give you a quick demo on the live system that we have built. It's an experimental system. It is built on API that we made it accessible to Al Jazeera, and we can make it accessible to anyone who is interested. Just contact us. It captures one search scenario. The user searches Twitter, get the tweets, and then see which of them are check-worthy, and among those, he or she can verify them. It is just an early integration platform for us to play with the features as early as possible, understand the problem better, get ideas, test the ideas, and also get user feedback. So I will now share quickly. So I will stop sharing this, and I will share my browser, I think.
How long it will take, Doctor?
Just 1 minute. So you see my browser now, I think, right? You see my browser?
Yes.
So this is the experimental platform that we have built. You search as you search in Twitter. You identify the order of tweets that you want to get. By default, it is Twitter, and you see here the bar here indicates whether this tweet is check-worthy or not based on our model. Okay, so here the tweets is talking about the results in Arizona in the US elections. Some of the tweets, of course, are not check-worthy, so you get a very low score. This is the order of Twitter. So you can also see the order based on check-worthiness of the tweets. So you see here there is a tweet about special security precautions on the hotel of Trump in New York. So that's a check-worthy claim from the point of view of our system. You can also grade them, and you can also, as a user, you can, if you didn't like one of the estimations of our model, you can uncheck that to indicate to us that this is not check-worthy, and we can update our model based on that. This okay, is yes.
Okay. I think this is the last thing, right?
Well, just one more slide. I will stop the slides now and the demo, and I will just share again the last slide. The takeaway messages: we developed AI solutions for the problem. Data now becomes available. Our experiments are promising, and the rumors spread differently across languages. I want to emphasize that our outcomes are not just publications. We have very valuable data sets. We have a live system that is running now, and everyone can actually test it or can play with it. We have an AI model that is the state of the art on that data set, on that task. And we also have outreached the community through research competitions and labs, through public seminars, and also through media coverage. Thank you. And
thank you very much, Dr. Tamer. I think we don't have questions. Time for questions, but maybe at the end we can, if I have time, we can ask. We can, capture some questions. Quite interesting project. Thank you very much. Are you in I think you're in collaboration with Al Jazeera. Are you in collaboration with others? Yeah.
At the moment, Al Jazeera is our partner, is our tester, but we might think of other also, because we want also to make this not only for journalists but also for end users. So we are trying to find out other end users so far.
And are you planning to go to other social media than Twitter?
No, the focus in the project is only on Twitter for now, but the models can be used, of course, for other social media.
Okay, excellent. Thank you very much indeed.
You're welcome.
We now go to the next presentation by Dr. Gianni Di Caro. He's associate professor at Carnegie Mellon University in Qatar, and he's going to talk about teams of aquatic area robots for marine environmental monitoring. Dr. Gianni, the floor is yours. Yes, we see the slide. Just make it full screen, please. Yeah, thank you very much.
Unmute yourself, please, Dr. Gianni.
Dr. Gianni, we don't hear you.
Dr. Gianni, you just need to unmute yourself.
Hello,
please.
can you hear me?
Yes.
Yes, we do now.
Okay, sorry, something was. So I was saying that in this talk I'm gonna discuss a few AI approaches that we have developed for tackling the research challenges of the Tarman project. The project is about monitoring and surveying marine or more in general aquatic environments. And the project in general aims at defining new solutions, efficient solutions for building information maps for measures of interest. So when I say information maps, I mean anything you might be interested in measuring in a marine environment, like a map of water temperatures or water depths, forces, development of coral reef, or even like an unfortunate oil spill. And we consider the fact that in these kind of scenarios, usually the regions to map are very large, and maps need to be accurate to be useful in practice, but we have to face noise and fluctuations in data. And usually we have a limited time budget. It can be a matter of hours or days or weeks, but in any case, we don't have any infinite time. So the Tarman solution concept to tackle this kind of challenges in scenario it consists in using an heterogeneous team of autonomous robots. Why? Because we can enjoy parallel distributed data gathering, and we can enjoy the integration of different sensory motor capabilities. And more precisely, the team is composed by unmanned surface vehicles, USVs, and unmanned aerial vehicles, UAVs, where the UAVs will be carried on top of the USVs for recharging. So when we use such a complex system to tackle some such complex problems, we face a number of core challenges. The first challenge is how to define joint plans for the team to achieve effective data gathering and therefore a good map estimation. And how do we implement cooperative control among the robots in order to ensure a safe navigation and a correct and efficient plan execution? And how do we manage the interaction and coordination between the UAVs and the USVs that are acting in two different parts of the space? And how do we provide and use ad hoc networking, given that the network, the system can be in remote areas, so we can't enjoy actually infrastructure network? In order to tackle all these major challenges, we have used and developed novel AI methods, and mostly for making prediction and decision-making under uncertainty. So I will actually discuss two examples, one for the case of how do we make plans, and the other for the case how do we manage interaction and coordination between UAVs and USVs. So let me start with how do we tackle computing joint plans for the team, because this is a very core, essential part of the entire story for a successful mission from the size of multi-robot system. Let me first explain a little bit what is a plan. A plan in a team specifies the action of the robot for the next, let's say, time slice, let's say the next hour, and consists of an assignment of locations to each robot to where to sample, to where go with the sensor and get new observation data. So basically, a plan is given an area to survey, a set of sampling location assigned to the robots, and actually the assignment of the robot is the form of a path, specifying the order to visit the sampling locations. I want to emphasize that where to send the robots next to sample observation data is a critical decision. In order to be able to do the right thing, to be able to build statistical accurate maps, given time budget constraints. This example shows the scenario here. In practice, I want to achieve something like this, a very dense, nice, beautiful, accurate map. This is for a depth map in the Broken Ridge near Australia. But usually I start with something which is very much undefined. I was saying an uninformed prior at the beginning. So what I have to decide is where I go to make observation, to sample data in order to revise this prior and get maybe a better prior now in a subsequent time step. And then I have to perform again this operation. Where should I go? What is the best place to gather data? And then, well, if I keep doing this, and if I do it correctly, eventually I will be able to create like the dense accurate map that I'm targeting to. But if I go sampling in the wrong place, let's say in not interesting places, like in this case, if I keep like going here, I'm never going to achieve the necessary accuracy that I need for this kind of scenario. So we are facing, so team planning in this context is a fundamental problem. And the idea is to find the most informative robot paths for sampling, given what I know, so given my current knowledge. So I need to maximize, let's say, the gathered information, the gathered utility. And actually, in the literature, this problem is referred to as a multi-robot informative path planning. And also, I want, since these guys are robots, that the paths are collision-free. And also, I want to support connectivity in order to let them sharing and talking and coordinating. And I have to face the fact that I have a limited time budget, I have noise in data, that I have external disturbances like wind and currents, and everything should happen online, real time, and being distributed. Because, by the way, solving this problem in centralized way is overwhelming. They are very much hard NP-hard problems for those who understand these kind of things. So basically, we are facing a very difficult real-world planning problem under uncertainty. But I want to point this out. If we want to deploy, really deploy autonomous robot teams in the real world, these are the problems we must tackle. So the idea here is, in this project, we are not only tackling one specific subproblem, which is about solving and monitoring in marine environments, but actually we tackle a way more general problem, which is a problem of considering path planning in a multi-robot system under a set of real-world constraints. And I want to point out that planning is at the very root of decision-making. Is a fundamental component of any advanced deliberative AI robotic system. So it's a core component that we are somehow developing. Now, how do we tackle all these challenges? It's a bit complicated, of course. I don't have time to go through all the details, but I just want to give just a very quick flavor. Then I will show an animation that show a little bit how things happen. So basically what we want to do is actually to identify a region where to go sampling, which is the one should deliver the most utility to make me understand learning my map. So what we do, basically, we go to the process of generating random regions in the form of ellipses, and then we score these possibilities as with Monte Carlo sampling, so again with random simulation. Then we identify one which is the best according to what we know, and then we refine this one, and then what we do is actually we partition this elliptical region in disjoint regions, and then we assign each one to our robots. Inside this, we do some further refining to identify a path to sample over the points that are of most interest. And overall, once I have this, the robot team can just go to the identified region, which is the most promising for sampling, and they can gather data and can share it and then update the underlying map. And by the way, if things don't go the way we expect, because we are simulating all of this, basically on our model, we are adaptive in the sense we can interrupt what we are doing and then make a new plan on the fly and identify a new most promising region based on what we know at the moment.
You have 2 minutes, huh?
Well, but I started very late.
Yeah, let's move faster, please.
Okay, so here I'm showing that I have an example of what I said. This is in the case of a team of 5 robots. They are learning a bathymetry map of 6 kilometers squared in front of Port of Genova in Italy, using a model of these robots, so very small indeed. There is 4 hours time budget, and there is 1 time slices for planning. So what you see here in the animation now is all these elliptical regions that have been identified as the most promising regions, and then the robots sample there. And then after they acquire information and the error for the estimations for the ground truth, which is this one, decreases, and then they keep moving, identifying new regions over time, because according to the new evidence, there is a new best place to go. And the system is fully adaptive, is fully cooperative, and you will see in this 4 hours time can estimate in a pretty good way with simple bots somehow a very complex map, which is the ground truth map. So this is one example of how we can tackle a very complex real-world problem with a mixture of simulation, Monte Carlo, Bayesian optimization, and a number of other concepts that are typical of AI. In the last 1.5 minutes, I want to show actually another example of how we employ AI techniques, in this case for dealing with the interaction and coordination between UAVs and USVs. What's the problem there? The problem is like the limited autonomy in terms of battery of typical drones, 15 minutes. So how can we use them for a mission that lasts 4 hours? Well, they can be carried by USV. They can fly, let's say, for their 15 minutes to gather mission data, and then they go back and land on the USV for recharging. So it starts from here and then goes and do their sampling action, and then go back and then land. Now, landing is a very complicated operation, because now we have 6 degrees of freedom that are not controlled by the robots, because there are winds, currents, and waves. So how do we do this? Well, we have approached this in 2 different ways. One is, first, we tackle a fundamental problem in AI robotics, which is the state estimation. A robot needs to know where it is, needs to know where it is relative to other robots. In this case, the drone needs to know where it is with respect to the USV. And we tackle this using a multi-sensor fusion. So the UAV has vision and ultrasound sensors. And then we feed this in a Bayesian filter, again, a major tool in AI nowadays. And then we use this information about the relative cause in order to control the landing of the robot. So you will see now in the video, here you see the what the drone is seeing has some visual tag to help how to land on the platform, which is, however, quite small. But then it can, doing this feedback-based optimal control and using this dynamic state estimation can actually do the job pretty well. In the future, we're gonna do this using a catamaran robot. A very last thing, we also have improved the overall process for landing using also a model-based, non-linear feedback-based trajectory control. Well, in this case, what we do, we actually learn through the realistic simulations the model of the waves and the model of motion of the USV. And then we use dynamic state estimation with a combination of this model to let actually the UAV approaching effectively and safely the USV. And then when it's in proximity, it will estimate and predict what is the right moment to actually land based on the wave motion.
Excellent. I think, yeah, thank you very much. Yeah. You have, okay, conclude, please.
I just said, I just concluded, I just said, I just brought a couple of examples, but actually we employ AI in many other ways because we need AI, we need intelligence to tackle real world deployment of robots in real world and challenging environments. So
thank you very much.
Visit the website to know more about this.
Thank you. Thanks a lot for the presentation. Have you tested this in Qatar, this approach?
Sorry?
Has this approach been tested in Qatar? I mean, have you tested it in Qatar?
No, unfortunately not because of COVID situation. We were starting our experiments actually in the golf club in Education City with our boats, but then there was the problem with COVID, and then all this was delayed. So actually what I shown with the real robots was in Italy, because we are partnering with
university. Yeah, okay. So I think maybe you need to interact, with the maybe Ministry of Municipality and Environment and other stakeholders, maybe to test this in practice and have something in practice.
We'll do it because
Excellent.
I mean we have actually 10 small boats, so we expect to do some fun things actually in this respect.
Excellent. Thank you very much. Thanks a lot. Let's go to our next presentation by Dr. Khalid Sha'ban, and Dr. Khalid is going to talk about optimized and secure demand response using smart meters and blockchain for the Qatari grid. Dr. Khalid, he's an associate professor at the University of Qatar. Dr. Khalid, the floor is yours.
Thank you, Dr. Munir. I think the previous presenter needs to stop sharing. Okay.
I did it, right?
Thank you. Yeah. Can you see the slides?
Yes, we do. Please make it full screen.
It's full screen.
Okay. Yeah, good.
Okay. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Thank you for the opportunity. Today I'll be speaking about an ongoing project, optimized and secure demand response using smart meters and blockchain for the Qatari grid. This is the second year of the project. I am an associate professor in computer science and engineering at Qatar University. So the first slide is the glimpse of the team. We are two PIs from Qatar University, myself and Dr. Ahmed Masoud, and we have professors from University of Waterloo with one PhD students there, and we have 3 professors from American University of Beirut with students as well as we have also 2 graduate students working with us. As the co-founder of the project is Kahrama, the main utility in Qatar. And the overview to start with is I would like to show how the smart or the grid, the power grid, the power network is evolving over time, the power starts from the generation and goes through a transmission network combined of transformers and cables, etc. And then you would have the distribution part that we are focusing on, which used to be as simple as having the power flows from transformers through the lines until it metered and then goes to the customers. Now, the advances of different things that introduced challenges that we are tackling in the distribution part includes things like renewable energies that are feeding to the network, as well as storage systems that can store power and release it later on, as well as the electrical vehicle charging stations. Those are new and challenging to the network in terms of making it as smooth and as regulated as it could be, as well as these challenges includes the customer part or the customer side, where there could be inclusion of renewable energy again, electrical vehicles that draw and give power to the house or the customer premises, as well as batteries and so on. So now the power flow even goes back and forth, and many challenges need to be addressed. So our project has a number of objectives, more than what I'm showing today, but these are the objectives that include AI development and AI-based techniques to tackle some of the challenges. So basically one part, and by the way, there will be by now in the smart grid, of course, the communications between the smart meters and the SCADA, or the control system, and that communication, we are also seeing some challenges in terms of securing it, etc. So here, one of the objectives of the project is to develop a demand-side management that are intelligent at the customer level, so that we are, or the houses or the customer part will be optimized in terms of making the best use of the renewable energy, as well as taking care of the assets of the utility, such as the distribution transformers, and how we make its lifetime longer and make it more efficient so that it's not overloaded, etc. So this is one objective and a challenge that we are employing AI techniques to tackle it. Another one is at the network level. So again, because of the introduction of all these various components, the voltages and flow of power may see some abnormality. So we're tackling that again with the introduction of some new AI techniques that will help solving the problems there. As well as the last part, which is one of the objectives, is to secure the communications between the smart meters and the SCADA system, and we're proposing there two-layer security. One is as a prevention technique using the blockchain technology, as well as the detection techniques, which will be employing again AI-based techniques. Now, again, this is the second year of the project, so I'll be highlighting what AI can take off in terms of roles in our project, but we have not published the techniques yet. So bear with me, I will just be mentioning what are the challenges and some of the preliminary results, but no details on the techniques themselves, as they are not published yet. So the first part, which is the customer level demand side management, we're looking into optimizing within the houses different loads of the customer. Some of these loads are controllable and shiftable, so things could be moved to, let's say, a washing machine could be moved from doing the working during the day hours when it's maybe the peak time, where maybe prices are high, maybe the transformer or the assets of the utility are overutilized, so things could be moved and shifted. as well as controllable, where, for example, thermostat-based appliances can be turned a little bit up or a little bit down according to, again, the situation that or the time of use of those components, as well as the electrical vehicles and energy storage system and PVs within the premises of the house. So we do that. We try to optimize it, taking again into considerations the conditions of the transformers, which is an important assets for the utility company. We have employed some AI-based techniques in doing this scheduling of the loads, and we're seeing promising results. And comparing to conventional optimization techniques, we're seeing even better results, and we're able to utilize, for example, in this snapshot of one of the experiments we're doing, we have two ACs and dishwashing machine and an AV in the house, and the signal or the price signal is coming from the utility. So as the price goes down, we will be scheduling these appliances to make use of those periods of low price, and then when the price goes up, you will see that we're making use of less of the power coming from the utility, and we're making more use of, for example, the battery that is in the EV, the electrical vehicle. So this is one part of the work, and we're not only aiming to optimize the current, having a current information of what is the load on the transformer, what is the price, but we're also looking into the future, where we want to predict the load, the future load of the house, and so that we have a schedule prepared ahead of that time. In that sense, we've been looking into the problem, or looking into.
Doctor, can you move faster because of time, please?
For sure, yes. I have only a few slides. I cut my slides down. So the prediction of models for forecasting the short and long-term electrical power load is basically a machine learning. It's devised as a machine learning problem to be modeling that model using previous days information, and also some other features of the day of the week and month, and as well as weather forecasted information. With that, we have some, we've kind of getting very good results in terms of predicting for households, and this is an example of what we're getting in terms of industrial customers. We are doing very good in almost catching what was the power consumption and the predicted values. However, still it's a little bit challenging when it comes to the individual houses and their consumptions. It may go up and down sometimes, and the prediction is not as good, but overall we are catching the trend that is shown in the data. The network level, we're working on AI-based volt and VAR optimization, where we have 2 time scales optimizing the voltage and loss of power. So we're minimizing that and using the two time scales, again using AI approaches to be having the least amount of power loss and the least amount of voltage variation. These are the results where our technique that is compared to conventional optimization techniques is being doing consistently better than the conventional one, and hopefully we'll continue on improving on that. And the work, again, it's not published yet in terms of the details, and hopefully we'll be doing that soon. Thank you.
Thank you, Doctor. Thank you very much, Dr. Khalid, for the presentation. I think we'll not have questions for, time for question. But anyway, if there are any questions, colleagues can always reach out to you directly or to us, and we can forward you any question we receive. And that's good that you have Kaharama involved, which is really good, and hopefully they'll be benefiting of the outcome of your project. Let's now go to the next presentation by Mr. Muhammad Zahid Kamil. He's from Texas A&M, and he is an undergraduate student awardee of Qnrf. And he's going to talk quickly about automated mitotic cell detection using transfer learning. Dr. Zahid, the floor is yours, and you have 5 minutes.
Thank you. Hello, everyone. I'm Muhammad Zahid Kamil. I'm from Texas A&M University, Qatar, and today I'll be speaking about automating mitotic cell detection using transfer learning. My team and I, Ms. Moza Shukri, Nujud Babu Kashisha, and Supervisor Dr. Jim G. and Ms. Iman Mechita. This project was funded by the Qatar National Research Fund. So I'll be speaking about why do we need to automate the mitotic cell detection, what deep learning architecture we'll be using, what data and pre-processing techniques to obtain the data that will be fed into the deep learning model, what did we observe and evaluate, and what can we conclude from the project. So why do we need to automate mitotic cell detection? Mitotic activity refers to the rate of cell division, also known as mitotic counting, to count the number of cells that are undergoing mitosis. And as usual, cancerous cells have a high rate of cell division, and it is an important biomarker in terms of detecting breast cancer. Now, this process of actually pinpointing and locating each cell which is cancerous or not is a very tedious and error-prone process performed manually by pathologists. So to automate this, mitotic cell detection is a solution to screen patients faster and provide much better accurate results in terms of mitotic activity. So what deep learning architecture we'll be using? As usual, we'll be using the convolutional neural networks, which is a subset of deep learning, and it is inspired by the animal visual cortex, and it is optimal method for classifying cancerous cells. Complex CNNs are made up of complex feed-forward neural networks. The main components in CNNs are convolution layer for translation invariance to better detect the horizontal and vertical edges, max pool to downsample, and only to pass to the important features of the image, and the fully connected layer for mapping the output. There's a brief introduction of convolutional neural networks to keep you up to speed. For transfer learning, we'll be using a pre-trained convolutional neural network. The reason why we'll be using a pre-trained convolutional neural network is to be able to create a model, to train a model much faster, and to be able to better detect these cancerous cells. And it is made up of 13 convolution layers and 3 fully connected layers. This CNN model is also modified with skip connections, to better detect and localize these cancerous cells, creating a UNet kind of architecture. The dataset that we have used is the ICPR12 dataset, and it consists of 35 high-power field images for training and 15 high-power field images for testing. We've used image processing to create these 96 by 96 patches from the 2084 by 2084 pixels original size, and we downsampled 96 by 96, where this dataset was actually annotated by the pathologists, and using that, we obtained the ground truth by binary thresholding the images to obtain the black and white images, as you can see below on the bottom right, and the normalized ground truth, normalized RGB images that is also be shown. Now, using these two, we fed this data into the deep learning model to be able to train and recognize these cancerous cells as it's continuously fed with these images, and as it updates its weights. So to evaluate the model, we need to find the confusion matrix. And finding the confusion matrix, we actually used something called the distance matrix, from the centroids. So as you can see, for a true positive, if the detected mitotic centroid is within a 10.2 micrometer range in pixels of the ground truth, then we can consider it as a true positive. And if it is predicted, if the mitotic cell is predicted but it is not present in the ground truth, then it is considered a false positive. And moving on, for the false negative, if it is not predicted but it is if it is not present in the ground truth but it is predicted, it is considered a false negative. And it is a true negative if it is not present either in the ground truth, if the mitotic cell is not present in the ground truth nor in the predicted output. And using these metrics, using these features, we created a confusion matrix where you can see we have a quite low number of false negatives, and we also have a little high number of false positives. But
Thank you.
we
Can you conclude, please?
Yes, but we can conclude that the low number of false negatives shows that the model is actually good at detecting these mitotic cells, and this novel method of using a pre-trained VGG16 that is actually used for normal object detection to classify can be improved to improve the classification accuracy. And this model, as shown, is a stepping stone or starting step in terms of detecting this breast cancer and to expedite the process of detecting breast cancers, and will be made, could potentially be made available across hospitals. Thank you so much for listening. Thank you.
Excellent. Thank you very much. Well done. Thank you for the presentation. And if you have any questions, then we'll come back to you. Okay. Maybe after this session, because the session might disconnect at 11. So our next presentation is with Ms. Abir Al-Maridi. She's a PhD candidate from Qatar University, and she's going to talk about smart healthcare system leveraging artificial intelligence and blockchain technologies. The floor is yours.
Can you see my screen? Yes.
Yes.
Okay, great. So I'll be talking about smart healthcare system leveraging artificial intelligence and blockchain technologies. But first, let's say why healthcare. Actually, healthcare is considered as a top priority worldwide, and the spending on healthcare is increasing yearly since the number of patients with chronic diseases increase rapidly, and incomparable with the number of healthcare givers, which raises many problems in terms of stability, scalability, delaying getting the services, and the most important thing is the risk of having a direct patient-doctor interaction, especially with the current outbreak. And finally, the traditional healthcare system suffer from communication among heterogeneous medical stakeholders, since each one has its own rules and regulation. Therefore, it was efficient to introduce artificial intelligence in healthcare applications in order to enhancement. In this project, we propose our health chain framework, where we introduce an environment for communication and data sharing between different medical stakeholders, such as the hospital, pharmacist, insurance company, and Ministry Public of Health, where each has its own rules and regulation. At each level or at each entity, they have their own local network where data need to be collected, processed, and then added some way into the blockchain manager. So here, into the blockchain. So here actually we'll be discussing artificial intelligence at 3 main levels: at the edge level, at the entity levels, and finally at the blockchain level. Starting with artificial intelligence at the edge level, and taking the hospital as an example, where we do have a huge amount of real-time data, medical data that need to be transferred from the patients to the smart hospitals. It's efficient, it's needed actually to apply some sort of compression to these data, and therefore we introduce Convolutional Autoencoder, where the convolutional encoder will be applied to the patient in order to compress the data and send it to the smart hospital, where the data will be reconstructed using a convolutional decoder. Actually, we apply the data type, we use its EEG signals, and we apply it on different type of data sets. One of them we were able to reach to a compression rate of 93% with a distortion rate of only 11%, which was really great. This work is also published in 2 conferences, where you can know more details about it. Moving to the second contribution in artificial intelligence at the blockchain level. Actually, as I said, we are trying, or we're targeting to having a priority-based secure data sharing system using the blockchain. And here we introduce a new logical role that will circulate among the health chain entities, which will collect a set of the transaction from all other entities, from all other entities, and these transactions, they have their own security and urgency level. We need to manage the trade-off of having these transactions with certain security and urgency level, along with the trade-off between the security, latency, and the cost, in order to update the configuration of the blockchain for efficient performance. By configuration here, we mean the number of transactions per block and the number of miners that need to revise this transaction. So this was done using a dueling double deep learning, a DeepQ network that solve this trade-off between the security, latency, and cost, and give us the best decision regarding the number of transactions and the number of miners for this block that will be generated and verified, and the blockchain will add it to the ledger in order to be shared with all other entities. Actually, our solution was able to converge during the training time using TQN and the D3QN. Both of them were able to converge, and at real time, DQN with its variation was able to adapt any drastic changes that happened. We introduced here 2 changes, and both was able to outperform heuristic approaches, greedy and random selective, and to stay having a good performance even if there is a change was introduced. Finally, artificial intelligence at the entities level, we are thinking of having a decision at each entity in order to decide whether to add this transaction to the blockchain or not, and decide how it should be sent. Like the context of the data, should it send as it is or at the index of the data? We are planning to use multi-agent reinforcement learning in order to manage the overall system performance in this term. So finally, I'll conclude by saying that convolutional autoencoder can be a good competitor for other approaches in terms of compressing the data with a very excellent distortion rate, and DQN network with its variation has a great performance to implement our intelligent blockchain manager. And finally, multi-agent reinforcement learning is a promising proposal for blockchain entity. Actually, deep learning as well, other deep learning approaches can be implemented at the edge level. I didn't discuss them here, I'm just going too fast. But we are also planning to have other classification and mapping approach at the edge level along with the compression. And this shows how important it is to have our intelligent healthcare system using the artificial intelligence. Thank you.
Yeah, thank you very much, Abir, for the presentation. Quick question,
what
could be the next?
As fast as possible. So,
sorry?
I try to be as fast as possible. So if you have any other questions, maybe we can discuss.
Yeah. So what's the next step to move forward? So what's the follow-up for this?
For the last step, we didn't start with it yet. Having the multi-agent reinforcement learning, having an intelligent entities like the intelligent at the edge level, at the entities level of the blockchain, along with having more processing at the edge level. We just ensure having deep learning works perfectly with compression. We need to have other classification and mapping approach in order to get the latency and security level of the data.
Okay, thank you very much. Colleagues, if you have any burning question, you can raise them now. Otherwise, you can always share the questions with us, and we will be communicating with the presenters, and they will get back to you. And regarding sharing the presentations, we'll be checking with the speakers if we can share the presentations, and if they are shareable, and also the session is recorded, then this can be shared with you. Of course, after asking your consent for sharing the presentation and as well as the video. Any burning questions, colleagues? I don't see, but I think from all this presentation, quite interesting on the strategy, on the different application areas, in health, in energy, in different sectors. I think that there is a need of cooperation. I believe more collaboration among the institutions and the stakeholder to really maybe align. I think we are aligned with the strategy, but to join work and joint effort together to achieve really something good, for Qatar. We are doing a lot of interesting work independently. I think we should maybe somehow join effort and be working more together. Maybe you need to think about a task force on artificial intelligence with the stakeholders. So you have any thoughts about that? Any of you, of the colleagues? You can speak. No, I don't hear from you. Anyway, the two Sanjay, are you with us?
Yeah, I'm here. Yeah, I think it's. I mean, the work that's going on is very good, and and if people find opportunities to collaborate, then they should, I guess. about the task force. I mean, I guess there'll have to be some objective. What will be the purpose of the task force? Will it be to encourage more local collaboration or more local impact? I think that's the key thing. So a lot of the work that's being done, I think if it can be translated into, where it can be applied in Qatar, that would be great.
Yeah, indeed. So I mean, one question is how to implement the strategy, how to go forward.
So yeah, so we've been working with different stakeholders, as I mentioned about the AI augmentation. We are writing a white paper in consultation with some stakeholders. Then we want to work with the Ministry of Education for the curriculum, the data science curriculum in high schools, and also with the Ministry of Commerce and Finance on the knowledge economy. So yeah, so we're trying to reach out to the different ministries and different government organizations. So that's how we are trying to see if we can implement the strategy. Also, I think the Ministry of Transport and Communication will set up a higher level committee to oversee the implementation. So yeah, things are in works, but yeah, I think I'm sure Qnrf will play an important role in this.
Yeah, there were some questions regarding the data literacy, because in the government sector, ethical dimension, and AI and use of AI in e-government and other sectors. So I think, and also we have a lot of outcome from our projects. We need, I think, to join effort and don't replicate or duplicate, but maybe benefit of what has been done already.
Usually it's good to start from things that we're doing in QCRI. We often start from a problem from a stakeholder. We say, okay, what is it? Tell us your problem. Like when you work with Carlo, when you work with the Ministry of Transport and Communication, you say, okay, what is your tell us your real pain points, and then we try and come up with a solution. If they have data, then it's an AI-based solution. So I think often, if Qnrf can encourage to have this bridge between industry and researchers, I think that would be like I'm not sure if Qnrf has a scheme. Like in Australia, we used to have a scheme called ARC linkage grants, where you had to have one. So there was a discovery program, which is fundamental research, but there was also the linkage grants, which was more about getting some formal involvement with the stakeholder, like a industry partner, and then trying to work on some problems. So.
Okay. I think we need to sit together and discuss it at some time, and maybe define like a roadmap of for the implementation of the strategy with QCRI, with the ministry, with our colleagues here on the platform, and also others.
Yes, that'd be great.
Yeah, colleagues, any comments? Any you want to say? No. Okay. So thank you very much.
I would like to just say one thing, is that I fully agree that there is a lot of expertise and there is probably the need for having a critical mass. And in my little experience, this usually applies and takes form when there is a concrete project with concrete funding. If we try to work on the void for some high-level objective, chances are that we will get distracted by our daily activities and our need for funding and the day-by-day activities. If we really want to do sort of coagulation of expertise so that results could be magnified, adding all our skills and experiences also on field, as I've seen during these presentations, we really need to come up with concrete projects with, as Sanjay said, clear outcome and adequate funding. That's just my 2 cents. Then yes.
Indeed. Thank you very much, and I hope we will be discussing it further later on. I would like to thank all the speakers, each of you, all the participants to our seminar. colleagues from everywhere. And thank you for the organizers, our PR team, Sheikh Abdullah Al-Thani and Wael and the team, and our colleagues in ICT team, Qnrf, Dr. Ahmad, Dr. Ali Aboudi, and Ahmad Ribai, our management, Dr. Absattar Al-Tai, Dr. Hisham, and all the colleagues who supported this effort. And I would like really to thank you for the good work, and wish you really to see some outcome really being implemented and used in Qatar, and also even in the region and the world. Thank you very much indeed for your time and your effort, and wish you all the best. Thank you, all of you. Have a good day.
Thank you.
A good weekend.
Thank you. Thank you.
There is a question there. People are asking if this recording will be shared and how. I think that's the last thing maybe you want to address.
We will discuss with our PR team and also seek your consent if you are okay to, with sharing the video. I will check if it is recorded, and if this is the case, then we'll be discussing it internally to make it available to the public.
It is recorded, Doctor, and I hope we have the consent of everyone who has been here, and everybody has been watched by hundreds of people today. So the link will be available on YouTube, inshallah, very, very soon.
Excellent. So the recording will be available.
All right. Thank you. Thank you, everyone.
Thank you, all of you. Thank you. Have a good day.
Thank you.
Bye. Take care.
Thank you. Assalamu alaikum.
Assalamu.